Welcome back. If you've come back, if you haven't come back, you can't hear this, so it kind of doesn't make much difference really. My name is still Rob Miles. I'm still teaching you about writing games for C Sharp and XNA. Last time we actually made a program. We got XNA onto our system and made the screen turn blue. Jolly fine thing it was too. This time we're going to take a look at stepping back a little bit at the business of programming and considering what makes a program, with the subtitle, what is it that computers do? The answer to this question seems to be go wrong, so you have to record the same session 3 times. So this is my third attempt. If this doesn't work, I'm going to go and stick my head in a bucket of cold water or something. What fun that would be, eh? How good that would sound. So here's hoping it works. We're going to look at what computers do and move on to how we control them ourselves, how we write programs and what tools we use and all that good stuff. Welcome to the world of games, programs and fun, basically. You can create XNA games using these skills, or you can actually write C# programs that do other useful things like word processors or any kind of program you like. I've scoured the world for lots of inappropriate clip art, so you'll get some of that on every slide, including this happy chap sat at the terminal who looks almost exactly like I don't just at the moment. We're going to start, by the way, by learning what a program actually is. A program is a list of instructions that tell a computer what to do. Two things you have to do to write a working program. One is to figure out how to solve the problem, and the second thing is to take your description of the solution and put it in a format the computer can understand and then actually obey. So 2 steps: solve the problem yourself and then express that solution in a form the computer can be made to do. This means that computers really aren't that all powerful. They can't do anything they haven't been told to. If I can't make a cake, I can't give you the recipe for the cake. Actually, my recipe for cakes is go to cake shop and move from there really. But if I was a really good cook, then I'd be able to write down the instructions for what I did to make that fantastic sauce or whatever and give it to other people to follow. If I'm a lousy cook, which is much nearer the truth, then I can't write recipes, and it's a bad plan to let me do that. There are things called artificial intelligence that try to make the computer behave a bit like a person or a human would, but some of these things just boil down to making the computer good at guessing, and you don't want programs that guess all the time. Most of the time you want a program that works, does the job and gets things sorted. So we're not going to be doing much AI. Occasionally we'll make programs that behave a bit like a human being would in that situation, but these are going to be very simple and not sort of taking over the world level. So there you are. Rather sad, but there you go. If you want to become a programmer, then 3 things I reckon you must need. One is a desire to learn new stuff, find out how to do things, experiment, play around. A bit of patience and persistence is also very useful because they don't work first time. You often have to work really hard to figure out what it is that the computer actually did wrong, so you can then fix the instruction and make it go right. Silly ideas are fine. If you want to write an XNA game where somebody hides the gamepad and another person has to find it and press a button before a timer goes off, if you want to have button pressing vibrating gamepad games, if you want to have flying toilets, if you want to have anything in your game, as long as you can dream it up, you can write a program to do it. So it's a great way to explore ideas and make new things work, and silly ideas are most welcome. There might even be a whole new type of game in the back of your head somewhere rattling around looking for a way to make it onto a console, and XNA could be the way to do that. What you don't need though is a massive brain. My brain's not massive and I can write programs just fine. You also don't require a lot of maths. There is a bit of maths, particularly in games. If you're putting things onto the screen and moving them around, there will be some numbers involved, but don't worry, It's not a lot, it isn't a huge amount, and we'll pick it up as we go along. The final thing you don't need is an attitude. If you start thinking my computer program is better than yours, in fact it's better than everybody's, then you're going to have a hard time, because almost certainly it won't be. I've written wonderful programs that do things beautifully and perfectly and show them to people and have them go, mine's half the size and goes twice as fast. And I have to go, oh, show me that then. And they show me and I copy it and I use it next time. I tend to write code and put mistakes in, and other people write code and they put mistakes in too. We find mistakes in each other's code and sort it out and keep on moving forward. Effectively, a computer programmer is someone that makes a computer do what they and perhaps other people want. So all the way you're doing this, you're moving towards some kind of a happy ending that makes people happy. And if you keep your mind focused on the happy ending side, then you'll be a happy programmer and you'll get on with other programmers a lot better and all keep moving forward. So keep that in mind. And don't be afraid to seek help, and don't get cross with people when their programs fail, and don't get cocky. My programs never crash, because I've never dared do that. It's just too scary. I know what my programs are like. They're good, but they ain't the be all and end all. So there you are. You're going to learn three things. Three things you must learn: the C# programming language, which is how we tell computers what to do; the XNA game development framework, which is a big pile of resources that help you make games; and a tool called Visual Studio, which is used to create, run and debug the programs. Take C# first. This lets you tell the computer how to do something. If I'm telling you how to bake a cake, I'm going to use a language which contains words like, or phrases like, put the cake in the oven at gas mark 6 for 2 hours. Okay, that's a language you can use to understand what I've done, told you to do, and then go off and do it. A sequence of simple steps. If I'm writing a program, I have to have a language I can use to express steps like move the alien spacecraft a little bit to the left and see if it's crashed into the rocket, kind of stuff. Now, those instructions are written in a programming language, which is this sequence of little steps we'll come to a little bit later on. And then a big program called a compiler converts this C# you've written, this sort of semi-English stuff, into instructions for the computer to follow. Then the program runs and you go, that's not what I wanted, and you have to change it and make it work right. So a programming language is a language you use to write programs. It's how you express your solution. XNA is a whole bunch of resources and stuff specifically for writing games. And there's big chunks of XNA are written in the C# language, and you basically call those in. It's a bit like having, if you're a master chef, then maybe you'll have some little chefs that come in and do sauces and pies and bits and pieces, and you go and get this, make me a nice beef sauce. Oh, okay, I will do that. I know how to do that, kind of thing. So the idea is that XNA is a bunch of resources you can take and plug into your games, and it's also an entire framework into which the whole game thing actually plugs and runs. It runs this thing called the game loop, which is every 60th of a second or so your game updates itself and redraws itself, and it's XNA that keeps that heartbeat going. And when you put your game together, you plug it into a framework that means it gets these vital, regular, reliable update messages and draw messages to keep the game going. So basically it's the place your game programs live. It's the place they actually fit into and run within. Okay, it's a framework that does that for you. The final thing you're going to use is Visual Studio, which is an integrated development environment, or IDE for short. It's where you write this C# stuff. It's a bit like a word processor for software. It also contains the compiler, so once you've written your software you press the run button and the compiler does its stuff, and it also contains a runtime controlling bit which lets you debug your program, see what it's doing, find out what's wrong and fix it. That's where the integrated bit comes along, because it has these three things where you write the code, where you compile the code, and where you run the code, and these all fit together to make this one single one-stop shop, this one place where you can work to actually get your programs written and running. It has lots of shiny buttons, which is always nice. You don't have to press all of them. In fact, there's some I hardly ever press, and one or two I've never dared press. But I'll come to that in a minute or two when we start actually writing programs and running them. So these are the three things we're going to be picking up on, and these are the three things you have to get your head around to actually write games. We've seen that a program tells the computer how to do things, and we've seen that we have these special languages that the computer can make to understand. There's C# is the one we're going to learn. There's also things like C++, Visual Basic, Pascal, Fortran, Algol. There are many, many, many programming languages. C# is a good one to learn because it's very popular, it's easy to use, and it's the basis of lots of really powerful programs used out there in the world. So good place to start, good tool to learn. Once you've learnt one programming language, you know how it is that you make computers work, and that means that moving to a second programming language is not actually that painful. You can, for example, move from C# into Java, should you wish to do that, with only small changes to the way you think about how the language works, which is quite nice. So we're going to write programs, we're going to use C#, and we'll fit into this XNA framework to actually write games, and we'll use this tool called Visual Studio to actually write the programs themselves. If you think about what a program actually is, it's basically made up of two things. The data, which is the stuff the program actually thinks about, and the actions, which is the actual doing part. Okay, so the data is all the information which the computer must manipulate to make the game work, and the actions are the set of C# statements that actually perform the required changes to those data items to get the game to work. As an example, let's take my Mystic game, which is a game which is Mystic, which I'll just go and find. If I go into here, and then I find that I've put it in the wrong place, so I've now got to go to here, and then I've got to go into here, and you can see all the stuff that's coming up. Isn't this wonderful? Let's keep on going down here and find the demo, and I'll start up Mystic game. Now it's just the same as what you were doing last time. I'll double click on this, and up will come Visual Studio. This is the game. It looks a lot like what you made, but I've actually filled it in with some bits and bobs and made a program that does stuff. So when I press the go button, the program will compile and run, and I'll just sit down here to find my controller, and the ball will start bouncing around, and my controller won't work, so I'm in the process of losing right now. Let's try you. Yes, you're good. So now I can move my controller up and down and bounce the ball off it. Whee! So this is actually a very simple game which you will have played a version of quite early on in your game playing career, I guess. There you go. I'm player one and I have won. Mind you, the other guy wasn't moving his bat, so that's fair enough. This is actually a very, very simple game. It just looks funky because of the way I've drawn everything and then spun it round and drawn it again, which is one of the things that XNA lets you do. I'll just take it away and go back to the presentation, which is this one here, please. Thank you. And try and figure out what it is that the game's actually storing. I've said that games are actions that do stuff and data that's held in the game. If you look at the game in like a snapshot, the game has to hold where the left bat is, it has to hold where the ball is, it has to hold where the right bat is, it has to hold the score for player 1 and the score for player 2. And then every time X and A goes tick, it has to move the ball a little bit, it has to move the bat if the players press the gamepad buttons, and then it has to check to see if the ball's hit the bat, in which case we bounce off the bat, or it's hit the back wall, in which case somebody has to earn or lose a point. So if you think in terms of what this game's doing, it's actually got a whole bunch of data, where the bats are, what the score is, and a whole bunch of behaviours, move the ball, move the bat, and that's what makes up our Mystic game. So what we know so far is that computers aren't clever. They just do what you tell them. They follow these instructions. We know that a program is the statements that describe the data the program is going to use, and then some more statements to describe the actions to perform on the data. And we also know we're going to write C# programs and use the XNA framework to make the games work. And the final thing we're going to pick up, of course, is that Visual Studio is the tool that brings all these things together. At this point we have a few true-false bits and bobs. I should really have a good buzzer sound effect, otherwise I do my throat in on the true-false things. But basically a whole bunch of statements which can be true or false. First statement up. Computers write their own programs. Wrong. We write the computer programs, the computers just run them. So when the computer starts writing its own programs, that's kind of like Terminator territory, and we're not there yet. And the more time you spend writing programs, the less likely it starts to seem to you that the programs will take over the world. So computers don't write their own programs. Statement is false. Okay, next one. XNA is a programming language. XNA is not a programming language. If you go back, you'll find that XNA is actually this game framework of bits and pieces that help us to make games. The actual language is called C#, and that's used for lots of things, a lot more things than games, but we're going to use it for games, and that's absolutely fine by me. Okay, next one. Visual Studio is used to write C# programs. Oh yes, it is. That's what you do. That's really why it's there. You type the programs in, you compile them, you run them, you change them, and you go round again. You have to have a huge brain to write games. Oh, give me a break. You don't. If you have an inquiring mind, persistence, a strong desire to succeed, and lots of daft ideas, then programming will be okay with you, and writing games will be fine. Okay, you don't have to have a huge brain to write games. Huge brains just make it hard to get through doors anyway. So as far as I'm concerned, they're not. They're somewhat overrated. A program is made up of data and anchovies. Pizzas have anchovies on. Programs do not. Data and actions would make a lot more sense. The program contains the stuff that describes where things are and the actions to perform on them. So that's wrong. C# is just for writing games. That buzzing noise is hurting my throat. Never mind. You can write all sorts of stuff in C#. You don't just have to write games. You can write anything you like. Games are what we're going to write because they're fun, but you could write your own word processor or payroll program or database or whatever you like, or web host or whatever you wanted, and C# is a great language to do that. And finally, XNA stands for Xbox is nicer than all other consoles. It doesn't stand for that. In fact, it doesn't stand for anything. It's like B&Q. It's sort of, some people say it stands for XNA is not an acronym, but that's just a kind of programmer's in-joke. Not everything has to stand for anything. I stand for pretty much nothing. I stand for ladies on the tube. That's what I do. I'm nice like that. But it's not something which has any particular meaning other than it's a great framework for writing games. So thank you very much for paying attention. We've had a look at what makes a program and what computers do, and no doubt we'll be doing something different next time.